Hi, we're Team 21 and we will be discussing plasma cutting robots. My name is Josanne Batson.
I'm Francisco Rincon.
My name is Kaveh Gharibi.
Humberto Mejia.
Here, actually, we are first. I'm discussing the main idea of plasma cutting, which is a sort of process that is used to cut sheets of metal and also pipes or different kinds of metals. As we can see in the this slide, this shows the whole
The torch holds the consumable
process of the plasma cutting. As you can see, the gas with high velocity comes into the nozzle, and then the electricity here makes an ignition, and the gas which is burning in 25,000 centigrade degree will cut the material.
Computer numerical control or CNC technology was integrated into plasma cutting machines in the late 1980s and into the 1990s. This gave plasma cutting machines greater flexibility to cut diverse shapes based on a set of instructions that were programmed into the machine. However, they were limited to cutting flat sheets of steel using only two axes of motion, or the XY cutting. Japan saw a birth of what came to be called high-definition plasma cutting at the end of the decade, and in the 1990s marked a turning point for plasma cutting. Plasma cutting became as competitive on mild steel as it was on stainless steel and aluminum. It became a cost-effective alternative to the emerging laser and the traditional oxyfuel. This is the late developments in plasma technology, where for air plasma, it goes from 12 amps to 120 amps. For conventional mechanized plasma, it's from 130 amps to as high as 1,000 amps. Then we have high definition plasma that we spoke about already, that emerged in the 1990s. And the high production sheet and plate cutting is a category that is receiving the most attention in terms of process research and development. As a result, high definition plasma cutting systems have made huge strides in quality and speed.
Why include robot technology in the plasma cutting? The automation help the plasma technology to get precision, to get safety, because it's a very aggressive environment for the human people inside. This is a very good work for a robot. With automation, we increase the productivity and low cost. The plasma cutting robot lets easy programmation and handling, reasonable investment, high cutting speed, precision, and quality, and very good result. In the early times, the serial arms in 3D are well developed to improve this technology. We can see how this 3D robot is working in this case. It can work in different shapes, pipes, planar sheets, etc. Sheet metal plasma cutting is very used in automotive industry and in the workshops in many industries is used. We can see the basic principle to use robotic in this technology. We have the power supply here, we have the gas supply here, and the gas hoses, the power supply cables, the electrodes inside the torch, and the mass connected with the work table.
We have new technology. The new models come with a smaller nozzle and thinner plasma arc. This improves the have a better precision. These are near laser precision that are used on the plasma cut edges. On the next slide, we can see how the combined technology is used by some companies. They use a precision CNC control where it's used on a control basis with a program, and the company is leading nowadays on the robotic industry and selling these plasma cutting robots are Motoman, KUKA, Panasonic, Fanuc Robotics, and ABB. On the next slide, we can see how a robot looks today. This is an ABB IRB 4400. This is the latest technology. It has a better precision cut. This is a 6-axis robot that applies the latest technology, as I said, in plasma cutting with highly improved precision and flexibility. So the future for plasma cutting robots are in the automotive industry and for parts in dairy industry applications.
So for our design, our task that we decided to do was cutting in a circle and a rectangle. So this is the workspace, and it is 48 inches by 48 inches, and then we have our different conceptual mechanisms.
We were analyzing the different mechanisms to perform this work with the plasma currents. Finally, we have three kind of mechanisms: this PP, and this RPP, and this PPR. And finally, we select this kind of mechanism with PPR planar robot. This is the most flexible robot we choose in 3D with 3DOF. In this case, with this this link here rotating in this, we can optimize this link. That is the best advantage for this selection.
First position problem that we have to do here is that this is the path that the end effector should go, and this is the circle path, and also this one is the rectangular path that the end effector should go. So we have to design the robot so that it can do as well. This is the robot, and this is the mechanism that we have designed and we modeled in the SolidWorks. As you can see, this is a prismatic joint, and this one as well is a prismatic joint. So this robot can, if you imagine that this is the sheet metal, then this can do the cutting process.
There are some pros and cons of our mechanism and our design. The pros are that the second link length will be reduced, so the system is way more flexible and you can cut more shapes than others. And the cons are that it has more link, which means it's a little bit more complicated and it needs more maintenance, more service and control of the instruments. For the conclusion of our project, On the survey part, we saw how the technology developments in robotics makes the machining and production faster, how companies prosper economically. And design, after brainstorming with my teammates, we came up with 3 designs, and we chose one of them according to the needs.
Thank you
Thank
for
you.
your patience.
And now comment below, give us thumbs up, you know.